Assalamualaikum and a very good day. So today we are going to learn regarding on application of nodal analysis to determine the voltage or current in a circuit. Okay, on previous class I already give lecture on application of mesh analysis, which is similar method to determine the voltage and current in a circuit. Okay, for nodal analysis, we are going to analyze circuit using node, and the node requires a solution of system of linear equation, and then this equation can usually be written by inspection of the circuit. Okay. These are the steps in order to analyze using the nodal analysis. Okay, the first step is to choose reference ground node, and then the second step is to assign node voltages to the other nodes, and then apply the Kirchhoff current law to each node other than the reference node. Express current in terms of node voltage. And then the fourth step is to solve the resulting system of linear equation for the nodal voltage. So basically, for nodal analysis, the principle of nodal analysis is to apply the Kirchhoff current law. If you remember, the Kirchhoff current law state that the current entering the node is equal to current leaving the node. And based on Ohm's law, we can express the current equal to voltage divided by the resistance. Okay. Okay, now we have a first example, which is a circuit consists of 2 ohm, 4 ohm, 6 ohm, and 5 ampere current source and 10 ampere current source. Okay, if you remember, the first step of analyzing the circuit using the nodal analysis is to define the location of the reference node. In this case, the reference node is at the bottom. Okay, why the bottom is considered as the reference node? Because all of the branches is connected to this reference node. Okay, and then next, the second step is to decide the node that can be considered as a reference point to determine the voltage flowing, the voltage of the circuit. Okay, in this case, this is considered as the first node. Okay, why this is considered as the first node? The definition of node is a point where two or more than two elements which is connected to this point. Okay, and then here we can see that 2 ohm resistor, 4 ohm resistor and 5 ampere current source is connected to this point. Okay, and then we can decide that this as our first node. So this is the first node. And then the second step is to determine the second node, which is, in our case, is node 2. This can be identified as the second node. Why? Because there are 4 elements that is connected at this point, which is 4 ohm resistor, 6 ohm resistor, 10 ampere current source, and 5 ampere current source. From here, we pick the first node, and we assume that all of the current is flowing out of the node. Okay, flowing out of the node. So this considered as I1, I2, and I3. So from the node 1, we can write an equation which is based on Kirchhoff current law. Current entering the node is equal to current leaving the node. Okay, in this case, all of the current is leaving the node. So we know that there are no current entering the node, which is equal to 0. And then equal to I1 plus I2 plus I3. Okay, and now we look at the current flowing at I1. Current flowing to I1 is in the opposite direction of with the 5 ampere current source. So we can write it as negative 5 ampere, negative 5. And then look at the current at I2. We realize that current at I2 is flowing from node 1 to node 2. And it flow across the 4 ohm resistor. So we can write it by plus V1 minus V2 over 4 ohm. Why we minus V2? Because we assume that there will be a voltage drop across the 4 ohm resistor. And then current flowing at I3, we can write it as plus V1 minus V0. We assume that the voltage at the ground equal to 0. So V0 equal to 0. And then it flow across 2 ohm ampere divided by 2. Okay, this is the equation for at node 1. Okay. And then we go to the node 2. At node 2, again, we assume that all of the current is leaving the node. Leaving the node. Okay, we can write it here as I4, I5, I6, and I7. And then based on Kirchhoff current law, current entering the node is 0 equal to current leaving the node, which is I4 plus I5 plus I6 plus I7. Okay, from here, we can write it that I4, the current is in the same direction as 5 ampere. So equal to 5, and then I5 is plus volt V2 minus V1 over 4 ohm. Why? Because we assume that current flowing to V1 will drop. Okay. Will drop. So we write it as V2 minus V1 divided by 4. Okay. And then for I6 plus V2 minus V0 over 6 ohm. And then for I7, V2, okay, for I7, the current is in the opposite direction with the current sources. So we can write it as minus 10. Okay, now we rearrange the equation. Okay. Okay, this is based on mathematics. Okay, now we have two equation, which is 6v1 minus 2v2 equal to 40. And second equation is negative 6v1 plus 10v2 equal to 120. Okay, so from here we can solve it using simultaneous equation. Okay, simultaneous equation. I'm using Casio calculator 570 ms. So the step to use the simultaneous equation, first you press mode 3 times, okay, until you found equation EQN. Okay, now you press EQN 1, and then there is two option, which is unknown 2 and unknown 3. Based on our equation, we have two unknown, so we select 2. Okay, for A1 will be represent as V1, so which is 6. And then B1, according to our equation, will be negative 2. And then the C1 is equal to 40. Meanwhile, for A2, which is based on our second equation, will be negative 6. And then B2 is 10. C2 is 120.